Good afternoon, students. Today we are going to study the last sections, Chapter 4.3, Radiation. The last type of energy transfer we are going to study in Form 3. How do we know there is a third type of energy transfer method, so-called radiations, in the universe? A typical example explaining why there is the third type of energy transfer is we can sense the energy, we can feel warmth from the sun. Even though there is a vacuum space between the sun and the earth, which makes conductions and convections do not take place. As both conductions and convections requires the particles for collisions, and for convections it requires the substance itself to move, to carry the energy from one place to other place. As a result, it proves that other than conductions and convections, there must be the third type of energy transfer existing in the world. And now we will call them as radiation. When we put our hands near, not touching the heater, we can still feel warm. Other than conductions and convections takes place here, radiation also contributes much to allow heat to transfer from the hot source to your hands. And we will use the word radiate, which means emits or release, or you can say gives out. But we will use the word in this section, radiate, comes from the word radiations to describe the directions of the energy transfer. When it comes to talk about the different examples of radiations, I must state actually there is an S here. It means that there are plenty of radiations that we've known. Example like microwave radiations, infrared radiations, UV means ultraviolet radiations, like gamma wave, X-ray. There are plenty of radiations, different examples of it. But in this chapter, as we are in the textbook for heat, so we are going to study only one of them, which is called infrared radiation. So the word radiations in these sections, we are implicitly talk about infrared radiations. Okay, so every object, including you and me, including whether it is hot or cold, every object will also gives out radiations, the infrared radiations. But the difference is, if this radiation depends on its temperatures. If the temperature is high, it will emit more infrared radiations than the cold objects. In the pictures below, we can see that the temperature is not even, but varied from high to low along these directions, or you can say from low to high to the right, along with the arrow. As we said before, both of them will emit infrared radiations, but the hotter objects will emit more, in all directions, than cold objects.